Here we are with example 1, where I'm going to try to explain what 8 to these fractional powers should mean by making it so there's a consistent pattern. So let's start with the ones we know. 8 to the 1 is just 8. 8 squared means 8 times 8, which is 64. And let's see, we can also use what we know about the negative exponents and 0 exponents. 8 to the power 0 should be 1, and 8 to the power negative 1 is 1 over 8 to the power 1, or just 1/8. All right, so what about all these other ones in between? Well, let's see. Going from 8 to 64 here, this is like multiplying by 8. So what would you, and going from 1 to 8 is multiplying by 8. Likewise, going from 1/8 to 1 is multiplying by 8. But what I want to do is say, every time you go to the right by 1/3 more of an exponent, so 1 plus another 1/3 is 4/3, plus another 1/3 is 5/3, plus another 1/3 is 6/3 or 2. So every time the exponent goes up by 1/3, can we multiply by the same thing here? Can I do 1 times something and then do that times something and do that times something? Let's think about what that would be. We'd be doing 1 times something 3 times, and the result should be 8, right? But thinking of like multiplying by this question mark 3 times, I want to write that as 1 times question mark to the power 3. And that result should be 8. That's what it means to go from here to here. So what should that question mark be? It's basically something that you can raise to the power 3 and get 8. That would just be 2. Because if you do 1 times 2 times 2 times 2, if you multiply by that question mark each time, you'll get 8. So let's see, if we do 1 times 2, that would be 2 here. And if you do that times 2, you'll get 4. And 4 times 2 is 8. So yeah, the question mark here is 2. And if we multiply by 2 again here, 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. So it looks like this pattern works. If we keep it up here, if we multiply this times 2, 1/8 times 2 is 1/4. If we multiply this times 2 again, you'll get 1/2. And if you multiply 1/2 times 2, sure enough, you get 1. So yeah, that's the pattern that we want here. Now, how do you get this 2? Well, 2 is something that you raise to the power 3 to get 8. That's also known as the cube root of 8. So it sounds like 8 to the 1/3 should mean the same thing as the cube root of 8 in order to make this pattern consistent. So that's going to be the general definition of what a to the power 1 over n is it's going to be the nth root of a. And what about a to the m over n? What if you have something else in the denominator? Well, let's see. You could think of that, I'm going to write it on the side here, a to the m over n. You could think of that as a to the m, and then that to the power 1 over n. Because you multiply the m times the 1 over n to get m over n. So that 1 over n you could think of as a cube root, or not a cube root, an nth root. So this could be the nth root of a to the m, or you could do it the other way. You could also think of this as a to the 1 over n, and then that to the power m, because it's still 1 over n times m gives you that m over n. So that would be the cube, or the nth root of a, whatever n is, but then taking that result and raising it to the power m. Okay, so that's what a fractional exponent means, is it means it's a radical or a root, but the denominator becomes the index of the radical, the kind of radical it is. So it's either a square root or a cube root or a fourth root. Okay, so let's do this exercise. If you understand that, here's a time to pause it, where we're going to simplify each of these using the definition here to write with radicals instead of fractional exponents. So this 1/2 power here, you're going to write it as a square root of x to the fourth. And then try to simplify it using what you know about radicals. If you get stuck, you can check your answers in a bit, but you still got to try them here. Okay, so let's look at this. The 1/2 means that 2 is it means we're talking about a square root. Of x to the fourth. So it's a square root of x to the fourth. What does that give you? Well, you want, whatever this comes out to be, whatever the answer to this is, should be something you can square and get x to the fourth. So what would work in there is x to the power 2, because then you can do 2 times 2 to get 4. Is that what we did up here? X to the 4 to the power 1/2, we just multiplied them. So multiplying by 1/2 is basically the same as dividing by 2. So 4 divided by 2 is 2. Now, taking the square root of this means we want to find something that we can square, which means something with an exponent that you can multiply by 2 to get 4. So saying what can you multiply by 2 to get 4 is the same thing as doing 4 divided by 2. That was probably hard to follow. If you followed it, that's great. If you got x squared and you're satisfied with that, that's great too. But I'm just trying to give some more reasoning for why this is the same as a square root. But anyways, the important thing is that it worked out using the exponent laws, and it also worked out using this definition. Okay, with this one, let's use this definition. We have 5 to the power 2/3. So if the denominator of a fraction is 3, that's going to become the kind of radical that we're talking about. So this one I'm going to think of as I'm going to use this version of it. We're going to take 5 to the power 1/3 is a cube root of 5. And then we're squaring that. 5 to the power 1/3 is the cube root of 5 also. All right, so what we have is a cube root squared times a cube root. Like you could think of this as just to the power 1 here, with these numerators becoming the number of copies you have. So if you have the cube root of 5 squared, and then that to the power 1, that's a total of 3 copies being multiplied. So you can just do 2 plus 1 to write this as the cube root of 5 to the power 3. And a cube root and raising it to the power 3 just cancel each other out to give you 5. And is that what we got before? Yes. So whether you use the exponent rules or whether you use this definition, we're getting the same thing. All right, let's look at this one. So this is a cube root of a squared b. That's what the 1/3 exponent there means. This 1/3 exponent is also going to mean the cube root of ab squared. All right, now what do we do with this? Well, if these are both cube roots, you can just combine this into one big cube root of a squared b times a b squared. And then you could just sort of combine the like factors by reordering it and do a squared times a is a cubed. B times b squared is b cubed. And that's the same thing as the cube root of a b cubed. And again, the cube root and the power 3 cancels out. So that just leaves you with a b. And that's what we got for that one before. Sounds good. Next up, you're going to practice using this with starting with some just values, and then some more examples with variables in them too. So give those a shot, and I'll show you the answers in the next video.